Okay, great. All right, so thank you very much, Dr. Dene, for your introduction, and also thanks to the organizers, Beranger and Ruben, for inviting me here today. So we've been immersed in this workshop for a good day and a half at this point. So radiocarbon, it's something that has been tossed around among the many elements that the presentation that preceded me have presented. I just would like to specify that this presentation does not intend to
Can you speak closer to your microphone, please?
It's not working?
Yeah, it's working, but it's a little...
Better now?
Can you speak?
Yes, is it better now?
Yeah, okay.
It's better?
Yeah.
Okay, great. As I was saying, this presentation does not intend to actually provide, to bring forward conclusions based on radiocarbon about archaeological or cultural or the cultural elements, but rather it's more about the discussion of the potential, the implicit potential and the limitations of radiocarbon dating as a tool to understand archaeological transitions, and particularly in this period between the early Bronze and the Middle Bronze Age. I would also like to specify that my examples are mostly drawn from my experience in Armenia and Georgia, but I do hope that my presentation will be useful also to those of you who work in other areas of the Kura-Araxes culture. So before I get to the actual, to the more technical aspects of this presentation, I would just like to go through a very brief recap of chronological studies on the Kura-Araxes in the South Caucasus. I'm sure you're all very familiar with this table, which is not meant to be exhaustive, but represents some of the many periodization systems attached to absolute dates that have been proposed over the decades regarding the development of the Kura-Araxes culture. Again, this is not meant to be exhaustive, but I like to use this to remind ourselves how much radiocarbon really shifted the perspective on the existence of the Kura-Araxes in time, particularly when Kura-Araxes proposed in 1983 first integrative chronology based on calibrated radiocarbon dates, many of which were obviously problematic, but the result of which was to really push back the beginning of the Kura-Araxes well into the 4th millennium and to really extend its overall duration. So obviously more proposals followed that one, which again was based on very scanty data. And again, we are in a much better situation now. We are also very familiar with this table, which is extracted from the special volume that was edited by Julien Palumbi and Christine Chatanier in 2014 regarding the Kura-Araxes culture. Again, the result of which is not too different from that first picture of a very long existence between the mid-4th millennium and the mid-4th millennium, but which didn't really resolve questions regarding periodizations, transitions between several stages, both within the Kura-Araxes horizon and in between the Kura-Araxes horizon and what preceded it and what followed it. So a lot of that is actually the result of a high degree of regionalization, which we are also very aware of, and which has been presented very clearly over the last day and a half of the workshop, to the point that actually Ruben Badalian proposed a chronology where regionalization really is a criterion of demarcation between two macro periods. So a phase of so-called homogeneity between 3500 and 2900 BCE, followed by a phase of heterogeneity between 2900 and 2500 BCE. Obviously, this is based specifically on the materials observed in Armenia, but in the Armenian territory only, we can observe, or rather Ruben and colleagues observe many regional variants, so the Karnushin Gavit, the Sheshmo-Kablur, the Ayhum Teut, and as we have seen from the data presented by Dr. Bobokian yesterday, also an emerging, as it seems, an emerging variant around Seran Lake. This data also correlates pretty well with what emerges from outside the territory of Armenia. So regionalization also in other territories, as for example, the case of the Shira-Kartli variant in Georgia, the Yernik Tepe in northwestern Iran, and the Kirbek Iraq in the Levant. this regionalization is so important, and Tony Sagona, in his synthesis in 2018, described 2900 BCE as a watershed in the Kura-Araxes tradition. Many are now starting to use the Rubens periodization also to adopting it outside of Armenia. And I am actually myself going to refer to this one in particular on the background of the critical aspects of radiocarbon that I'm going to comment in the next few slides. So this slide represents essentially the phases of Rubens periodization plotted on the radiocarbon calibration curve. You may be familiar with this kind of graph, but for the sake of clarity, the y-axis represents the radiocarbon age in BP years, non-calibrated, and the x-axis represents the calibrated age in calendar years BCE. Now, the blue line obviously represents the curve itself, which demonstrates the variation of the C14 concentration in the atmosphere over time. In an ideal world, this would look like a very straight line, and that if the concentration of radiocarbon will be constant, but we know very well that that fluctuated over time. So whenever we calibrate a radiocarbon measurement, what we're really looking at is how this value intersects, how and where it intersects the calibration curve to produce a calendar age. Now, the situation is pretty nice when we intersect a very straight line on the calibration curve, which resembles what the, as I was saying, the ideal straight line concentration would look like. And in those cases, we can essentially obtain very refined spans for our dates. So essentially, precision is pretty good in this area, and that is the case of the area between around 2900 BCE, which also demarcates the distributional dates in Rubens periodization. Now, it is way more problematic when the radiocarbon value intersects the area, the curve where a lot of fluctuation occurred. In technical terms, these are called wiggles because of their shape. And essentially, what happens is that for one point on the radiocarbon age intersecting this particular area, we will have many possibilities available for the corresponding calendar age, which results essentially in a very large uncertainty. And that's exactly what happens within the two phases, Kura-Araxes 1, Kura-Araxes 2, again as defined in the periodization that I'm using. So essentially, then these dates necessarily calibrate to this very large span encompass between 3500 and 2900 for the Kura-Araxes 1, and for the period that is of most interest to this workshop between 2900 and 2500. Something similar can also be observed for the post-Kura-Araxes period. So again, we can see a straight line around 2500, which usually is pretty easy to distinguish in the calibrated spans. But the situation is again a little bit problematic for what follows between 2400 and 2200. This situation is both a blessing and a curse in a way. On the one hand, because clearly it's important that those phases reflect the calibration curve, because this point of precision is also tied to an observable change in the material culture, what we call the heterogeneity. So we know that only after 2900, more or less, we observe this widespread heterogeneity, but not before that point. On the other hand, of course, it is very difficult to distinguish let's say subgroups of changes, like finer changes and finer dynamics that place within the entire Kura-Araxes 2 span, and the same for the post-Kura-Araxes. Another reason for considering this situation informative is the fact that the calibration curve itself can be regarded as a proxy for solar activity. So solar activity is really important in regulating the production of C14 in the atmosphere. So when the sun is really active, the solar winds block cosmic rays from actually reaching the Earth atmosphere where radiocarbon is formed. So essentially, when the sun is active, there is not a lot of production of C14 in the atmosphere. But when the sun is less active, that production essentially follows its natural course, producing what we see in those straight lines on the curve. So essentially, the period, that means that the period between around 2900 corresponds to what is called a grand solar minimum, where the solar activity essentially dropped and allowing C14 to be constantly produced and therefore constantly decaying, producing this very nice and straight line for our calibration purposes. So I'm not suggesting necessarily a deterministic approach in subordinating human history to climate, but I think it is curious and it is interesting that that heterogeneity really only follows this particular point in time, and one is left to wonder to what extent fluctuation in solar activity may have played a role in the settlement reorganization that we observe after this period. Again, obviously more data will be needed, but this seems to, at least that is my impression. This also seems to be suggested by other climate studies, particularly by the group of Joanne and colleagues, who have identified fluctuations toward 3000 BC, if I'm not mistaken. But what does this problem with calibration actually means for our use in archaeology and our possibility of distinguishing changes from continuity in the archaeological record through time? So I'm trying to demonstrate in this slide. I'm trying to demonstrate this problem by using a little bit of reverse engineering. So instead of looking at the existing data, I try to simulate what the radiocarbon span looks like for non-calendar dates at 2800, 2700, 2600, and 2500 BC, which falls within the later phase of the Kura-Araxes culture. So these spans are supposed to contain the calendar date for which I simulated them, and they do. But it is immediately evident from this plot that by simply eyeballing the graph, it is really not all that easy to distinguish true dates around 2800 from those around 2700. The situation seems to be a little bit more awful for the simulated radiocarbon dates for the 2600 calendar date, because the span do contain 2600 and they also tend to be shifted towards the later end. However, that does not eliminate the problem that they could easily be confused with radiocarbon span simulated for the true calendar date of 2500 BCE. And nevertheless, the rest of the simulated spans for 2600 essentially overlap by a lot with everything else that has been simulated in this graph. So two takeaway messages from this: one, that again, which is pretty intuitive, but it's not a bad idea to remind ourselves about that, is that it's really dangerous to rely on isolated radiocarbon dates when not in the presence of a longer series, because they can be misleading. And the other one, that it is also problematic to distinguish cultural changes based only on the distribution of radiocarbon dates, because those they may not necessarily be representative of the particular timing that we're trying to target. And the same thing can be observed also for the post-Kura-Araxes period. As I mentioned earlier, the 2500 point is falls on a rather straight on a slope on the curve, but not what follows it. So again, I simulated a series of radiocarbon dates for a calendar date on 2400, 2300, and 2200. And again, we can see that it's not like, for example, dates between radiocarbon dates for 2400 and 2300 are not all that distinguishable one from another. Again, in general, it is possible to distinguish those ones, these ones, from the ones simulated for 2200. But again, we will have single spans. They may be confused with those ones. You may think that this is maybe less of a dramatic situation because we're dealing with, in general, fewer centuries compared to the late Kura-Araxes. But nevertheless, this is important, especially if we're hoping to distinguish between archaeological horizons, as is the case of the early Kurgan period, which is marked by great acceleration in changes and a great number of expression manifested in the archaeological in the material culture. So on top of the calibration problems that I just discussed, of course, when we're looking at the older data sets, we have a number of other issues. many of which hopefully have been resolved by now. But again, I plotted here a few of the older radiocarbon data sets that were obtained mostly before the 1990s. We're not dealing obviously with a very large data sets. In addition to the calibration issue, which is intrinsic to radiocarbon, we can also note problems with lab treatment. Less efficiency in getting rid of contamination, for example, which may have produced problematic spends. That is very true for all radiocarbon dating, even in the West, and not just for Soviet labs, as naturally scientific techniques keep improving. And we are now much better at getting rid of contamination and understanding it than we were several decades ago. Another problem is the large uncertainty, which is not particularly useful. That is evident in the first date, which was obtained on Kurgan-4 Markopi. I believe this has a span of plus or minus an uncertainty of plus or minus 100 years, which again, not particularly useful if we're hoping to fit it into some series, some coherent series. Another set of problems is obviously the one regarding the association between sample and events. Again, this is something that is obviously being implemented, and archaeologists are much more aware of this by now, but back then it was not always the case. So that it was a problem, for example, when even in talking about Kurgan context, really it was not the inhumations or the burials that were dated, but it was, for example, the wood from the Kurgan cover or other samples there of a little bit more of a problematic association. That it is the case again on Kurgan-4, where all these dates were obtained on wood samples from the wood cover, and that relates to the whole issue of selection of privileging short-lived samples from long-lived samples. Now, obviously, seeds, for example, deposited with the burial or with the particular domestic context domestic context of interest, which are in situ, will be more likely to be associated with the activity that we're actually trying to date. Long-lived samples are more problematic, and that is the case of, for example, of undetermined charcoal or undetermined wood, because especially in the absence of very detailed characterization, we cannot really be sure whether the inner rings or the later rings were selected. So we don't really know how much of that offset is actually represented in the resulting radiocarbon date. We should also be fair and say that the fact that a lot of long-lived samples were dated before was also because AMS dating was not available. So it is now possible to date much fewer quantities of material. And in general, even today, in the absence of short-lived material, it's still okay to select the long-lived as long as we characterize it enough to take account of the intrinsic problem that we may observe then in the dating over context. And finally, another issue is that of replication. So we don't have a long series for many of these contexts, some of which are only represented by a single date. In green, I highlighted a couple of examples where the same context was redated recently. So, for example, here you see a date on the Markopi Kurgan-4 published in Savona, obtained on, again, wood, but this time with a much clearer identification. It turned out to be a long-lived species, oak, but the date, it's much more refined. And again, another small series of dates obtained for Bedeni Kurgan-5, two of which were obtained by Dr. Barreto at the Weizmann Institute. The other one, again, published in Savona 2018, which demonstrate immediately the inconsistencies with the only available radiocarbon date until new dates were obtained. Obviously, much of the issues that I've just illustrated hopefully are behind us when we're looking at the newer radiocarbon data sets. Here, I reported some, but not all, of course, of the available radiocarbon data that has been obtained, especially after the 1990s, and even more so after the 2000s. So in cases where the conditions allowed it, obviously it was possible to obtain entire series, and which much better practices of selection and interpretation of the data. But this has not exactly, despite those important improvements, this has not eliminated the problem in the background, which relates to the intrinsic uncertainty of calibration during the period of our interest. So what can we do to actually address this challenge and make radiocarbon dates useful to address our questions? In this slide, I'm trying to again illustrate this with a brief simulation, and later on I will also show a couple of examples from real archaeological data. So here I simulated two dates that fall on a problematic area of the calibration curve between 2600 and 2500 BCE, which is also the time of interest to this workshop. So I simulated one date I simulated a radiocarbon date for a calendar date to 2560, and then another one for a calendar date of 2500. In this simulation, day one is supposed to be earlier stratigraphically than day two, but by looking at the calibration itself and only, day two appears to be earlier than day one. So that's what's called an upright age inversion, which is the result of this particular shape of the curve and the fact that those values, those radiocarbon values intersect the curve at those particular points. So we will not get a very we will not very fair idea about the actual timing of the two events that are related to these dates. But if we integrate our stratigraphic knowledge within a Bayesian chronological modeling, then it is possible to rectify that issue. So in the top left, I modeled these two simulated dates in a sequence. So essentially, day one precedes day two, because that is the knowledge that we have from stratigraphy, and that is by all means reality. So in this box, the two dates, day two is essentially subordinated to day one, and that allows for a high degree of definition of the calibrated span. So what you see here in light gray is essentially the original unmodeled calibrated span. In dark gray is the output following the combination of radiocarbon with the stratigraphic information. And that is immediately, can be immediately appreciated when plotted again on the curve, where that situation of apparent age inversion is rectified by including this stratigraphic information. This is also what is called an informative prior, because of the information about the actual temporal relationship, the spatial relationship. In some other cases, we may not be as lucky as to have that much stratigraphic information. So I also presented a situation in which the two dates are not from superimposed layers, for example, but let's say two dates related to the same layer or to the same or two features that are not stratigraphically, do not cross stratigraphically, but relate to the same occupation, for example, at a site. Bayesian modeling is still possible. We will simply not be able to apply a sequence, and we will instead use a phase where the dates are not assumed to be internally ordered, but to relate nevertheless to the same event or occupation or activity of interest. You will see immediately that high degree of definition that was possible with this simulation is not occurring here. If you look very, very closely, you see a little bit of light gray on this side, but essentially that is a result of two things. One, the fact that we only have two dates for this particular, let's say, archaeological activity. And two, because we don't have a lot of information of what precedes this grouping of dates and what follows it. Actually, you've seen an example of that in Julian's presentation this morning. So in cases where we have other dates from other occupations that can be stratigraphically ordered, then the model will be much more informative. So this should be, again, hopefully an encouragement towards really maximize our stratigraphic knowledge to incorporate it with our interpretation of radiocarbon dates. And again, back to real data. I'm here proposing an example based on the recent work that has been undertaken at the site of Gagarot, which has been excavated by Ruben and colleagues within Project Kura-Araxes. Actually, I believe Ruben has shown briefly an example of the Bayesian modeling, Bayesian model that has been completed by Stormanning on this in the presentation yesterday. So again, I selected for the sake of explanation two dates that relate to stratum 1B at Gagarot, which corresponds to the Kura-Araxes 2 occupation marked by Carnouche and Gavit materials, and which unfortunately follow on that very problematic area of the calibration curve. So again, a very large span encompassing the entire, or essentially all the possibilities for the corresponding calendar dates between 2900 and 2600, almost 25 actually. But by combining them in a Bayesian model following the principles that I've just illustrated, it is immediately evident how much that really contributes to refine the uncertainty. So this is actually a zoom in on a much larger model that was published in Antiquity by Manning and colleagues, where again, these dates are arranged within a phase as relating to stratum 1b, but you should imagine this box again preceded by the grouping of dates related to the preceding stratum, and then the grouping of dates related to the following stratum. So that really improves the situation by a lot. And if not appreciated at the level of the individual dates, it can be even more so appreciated when we're looking at the summary definition, the summary refined span for the entire occupation of stratum 1b. So on the left, we have the unmodeled, what the unmodeled situation would look like, where we have like about 300 years or so. And on the right, the result of the modeling, where these uncertainty has been shrunk to about 150 years and 95%. You may say that is still a pretty large span, but not so much, especially when we're hoping to combine this with like broader regional comparisons. So we're no longer talking about an end of K2 at Geggeroth around 2600, but we can talk about an end at 2700, which puts things in a bit of a different perspective. So there is a lot of potential in adopting a site-based Bayesian chronological modeling for really refining our understanding of the fragmentation of the Kura-Araxes culture during the latest phase of existence, the Kura-Araxes 2, and then its relationship with other cultural changes occurring in the landscape and during that time. And again, Bayesian chronological modeling can also be very useful to discern other problematic area, to discern changes around other problematic areas of the curve. If you remember, I mentioned this particular area between 2600 and 2500 with an example of age inversion. Here, in the top left, the plot represents the one date from our copy published by Savona, which is essentially the most reliable one of the ones available for Marcopi Program 4. And then a set of new dates, again, that Ruben has shared briefly yesterday in his presentation, obtained from the site of Aigavan on serials from stratified layers. And a very simple sequential model allows to refine the date for Aigavan, for example, which in Armenia represents the very end, the very last manifestation of the Kura-Araxes culture. We have a bit of definition. Of course, these dates are not enough, and I do plan to get more, but just to demonstrate how much that precision is informative, when we try to plot, this is a correlation plot that essentially compares the refined date for Aigavan against the one date available from a copy. So essentially there is overlap exactly around the refined range for Aigavan, which is obvious because that is the range that benefits from the most resolution. So, but we're not really able to discern whether Marcopi could have really existed before or after or exactly around the same time, because this date, first of all, it's an isolated date, and second, because the span is still too uncertain. So I'm aware that I'm comparing two different geographical realities in this slide, but nevertheless, I chose this example because this is what we're potentially aiming to do when we're like talking about broader changes over the landscape. So we're hoping for more precise comparisons, and in order to obtain informative historical synthesis. So with that in mind, I am here just running through a few hopefully takeaway messages from this presentation. I think the first 3 points are pretty intuitive, and a lot of them are already being implemented in current radiocarbon dating practices in the South-Caucasus. I would like to emphasize particularly the last point, which is that of really on top of obtaining, not just on obtaining reliable data well characterized and well stratified alongside clarified archaeological interpretations of the assemblages, we should also maximize our archaeological stratigraphic knowledge to incorporate Bayesian modeling already, if possible, maybe even in the process of excavation, to inform our site-based and regional chronologies. I am myself in the process of obtaining, of collecting more samples and obtaining more data to address some of the issues that I've illustrated, but obviously that is a work in progress, and I do hope to be able possibly in the near future to share more data. But on that note, thank you very much for your attention, and I would also like to acknowledge the many people and the many institutions that have been supporting me and are continuing to support me in my dissertation research. So thank you.